Hello students. Now we will discuss global monthly average total ozone amount. Ozone is a highly reactive molecule that easily reduced to the more stable oxygen form with the assistance of a catalyst. Chlorine and bromine atom destroy ozone molecule through a variety of catalytic cycles. In the simplest example of such a cycle, a chlorine atom reacts with an ozone molecule, taking an oxygen atom to form chlorine monoxide ClO and leaving an oxygen molecule O2. The ClO can react with the second molecule of ozone, releasing the chlorine atom and yielding two molecules of oxygen. The chemical shorthand for these gas phase reaction is like this. A chlorine atom remove an oxygen atom from an ozone molecule to make a ClO molecule like this. This ClO can also remove an oxygen atom from another ozone molecule. The chlorine is free to repeat this two-step cycle. The overall effect is a decrease in the amount of ozone, though the rate of these processes can be decreased by the effect of null cycles. More complicated mechanisms have also been discovered that lead to ozone destruction in the lower stratosphere. A single chlorine atom would continuously destroy ozone for up to 2 years. The time scale for transport back down to the troposphere, were it not for reactions that remove them from this cycle by forming reservoir species such as hydrogen chloride HCl and chlorine nitrate. Bromine is even more efficient than chlorine at destroying ozone on a per atom basis, but there is much less bromine in the atmosphere at present. Both chlorine and bromine contribute significantly to overall ozone depletion. Laboratory studies have also shown that fluorine and iodine atom participate in analogous catalytic cycle. However, fluorine atoms react rapidly with water and methane to form strongly bound HF in the Earth's stratosphere, while organic molecules containing iodine react so rapidly in the lower atmosphere that they do not reach the stratosphere in significant quantities. A single chlorine atom is able to react with an average of 1 lakh ozone molecules before it is removed from the catalytic cycle. This fact, plus the amount of chlorine released into the atmosphere yearly by chlorofluorocarbons and hydrochlorofluorocarbons, demonstrate the danger of CFC and HCFC to the environment. This is observation of ozone layer depletion like this. The ozone hole is usually measured by a reduction in the total column ozone above a point on the Earth's surface. This is normally expressed in Dobson unit. Abbreviation of this is DU. हम इसको DU से represent करते हैं. Dobson unit. The most prominent decrease in ozone has been in the lower stratosphere. Marked decrease in column ozone in the Antarctic. Spring and early summer compared to the early 1970s and before have been observed using instruments such as the Total Ozone Mapping Spectrum TOMS, Total Ozone Mapping Spectrum. The amount lost is more variable year to year in the Arctic than in the Antarctic. The greatest Arctic declines are in the winter and spring, reaching up to 30% when the stratosphere is coldest. Reactions that take place on polar stratospheric clouds play an important role in enhancing ozone depletion. PSC, polar stratospheric clouds, form more readily in the extreme cold of the Arctic and Antarctic stratosphere. This is why ozone holes first form and are deeper over Antarctica. Early models failed to take PSCs into account and predicted a gradual global depletion, which is why the sudden Antarctic ozone hole was such a surprise to many scientists. It is more accurate to speak of ozone depletion in middle latitude rather than holes. Total column ozone declined below pre-1980s values between 1980s and 1996 for mid latitude. In the northern mid latitude, it then increased from the minimum value by about 2% from 1996 to 2009 as regulation took effect and the amount of chlorine in the stratosphere decreases. In the southern hemisphere, mid-latitude total ozone remained constant over that time period. There are no significant trends in the tropics, largely because halogen containing compounds have not had time to break down and release chlorine and bromine atoms in tropical latitude. Chlorofluorocarbons and other halogenated ozone depletion substances are mainly responsible for man-made chemical ozone depletion. The total amount of effect halogens में से chlorine and bromine in the stratosphere can be calculated and are known as the equivalent effective stratospheric chlorine. A study by an international team of researchers published in Nature found that since 2013, emissions that are predominantly from northeastern China have released large quantities of the banned chemical chlorofluorocarbon 11 into the atmosphere. Scientists estimate that without action, these CFC 11 emissions will delay the recovery of the planet's ozone hole by a decade. So, scientists have attributed ozone depletion to the increases of man-made halogen compound from CFC by combining observation data with computer model. These complex chemistry transport model work by combining measurement of chemicals and meteorological field with chemical reaction rate constant. They identify key chemical reaction and transport process that bring CFC photolysis products into contact with ozone. थैंक यू. नेक्स्ट लेक्चर में हम स्टडी करेंगे ओजोन होल एंड इट्स कॉजेस.